Welcome back to another video with Coding with Eric. Today, we're going to be thinking like a Google engineer. And before we start, let's click the subscribe button in the bottom right hand corner. Here's a simple interview question made by Google, and I want to walk through every step to help you start thinking Googlier. So, let's look at this question. In a list of numbers, find two numbers that sum is 14. Okay. So let's say we have a list and a list of arbitrary numbers, but let's also pretend this list is sorted. Therefore, since it's sorted, it's going to be going in ascending order. So we can assume that within this list of numbers, that one of the numbers will be x, one of the numbers will be y, and that x plus y is equal to 14. So if we're looking at these numbers, we can see that 5 and 9 are the two numbers or the pair that sum is 14. So let's take a step back. The first thing that probably comes to your mind is, okay, we'll just create a nested loop. We will grab the first index and we will loop through every index within this list and see if the first index plus the other indexes equal 14. If not, we'll move to the next index and then add that number with all the other indexes to see if that number is 14. But is that the best solution? Well, let's investigate the solution and see if it is. So let's find out. So let's start with the 0 index, which is 1, remove it from the list, and add 1 to all other numbers in the list. So 3 plus 1 equals 4. 5 plus 1 equals 6, 7 plus 1 equals 8, and so on and so forth, where 8 plus 1 equals 9, 9 plus 1 equals 10, 10 plus 1 equals 11, and 12 plus 1 equals 13. So if we look at the solution of all these numbers, we find out that 4, 6, 8, 9, 10, and 11, and 13 are all not equal to 14. So let's move up an index and look at the first index, which is 3, and we'll do 1 plus 3, which equals 4, 5 plus 3, which equals 8, 7 plus 3, which equals 10, and then we get the solutions for the other numbers, which is 11, 12, 13, and 15. Again, none of these numbers are equal to 14. So, let's move to the next index, which is 5, and we find that 9 plus 5 is equal to 14. And that 10 and 12 doesn't actually operate because we found the number of 14, so we returned 14, so we did not execute 10 and 12. However, what's the issue with the solution? Well, it's fairly slow because we have to loop through every index multiple times. But let's write up the code anyway and see if we can make it better. So I have the list by Google, which is 1, 3, 5, 7, 8, 9, 10, and 12, and the sum that we need to get from the list, which is 14. Let's start by creating a function called findSolutionNum. This function will take in two parameters, which is Google list param and the sum from the list. Let's now write a loop that'll go through the Google list. So for x in Google list param, we want to capture the index of this element, so equals Google list param dot index of the x element, and then write a loop within this loop that is for y in Google list param, capture this index, so y index equals Google list param dot index of y. If x index is equal to y index, then continue. So what are we doing right now? Well, we have a function which is called findSolutionNum. We have for x in Google list param, so in the list that is coming in, which will be this Google list, we capture the index of the element of the loop we are looking at. We write another loop using the same list, capturing a new element called y. And right here, I am comparing if x and y element are the same element. So if we have the same list running twice, I'm making sure that we don't do 1 plus 1 and duplicate elements. If we are using the same element, let's continue and redo the loop on the next element. So now let's say if x plus y is equal to sum from the list param, we want to return true. And for this example, let's make sure we type in a print so we can see it in the terminal. If we loop through the entire list and see no solution that equals 14, we want to return false. And again, for this solution, let's type in print false. Now, let's call the function. So find solution by num. We'll pass in the Google list, and we'll pass in sum from list. If we run this, we'll see that it's true, as it found 5 plus 9. If we change this number to 51, and we rerun it, it will appear to be false because no pairs equal 14. This solution is slow though, because we have to loop through every single element. We grab 1 and we loop through every single index from the list to see if 1 plus that number is equal to 14. If not, we grab 3 and do the exact same thing and go through every single index in the list. Let's hop back to the other video to see if there's a better solution. Well, we found the solution by looping through every index. But is there a quicker way that's not in log? Well, we know since it's a sorted list that the first index will be the lowest possible number. And the last index will be the absolute highest possible number. And that all numbers between are either duplicates or between the lowest and highest index. Therefore, if the sum is less than 14, we can increase the lowest index by 1. So we can increase 1 to 3 and then 3 to 5. If the sum is greater than 14, we can decrease the highest index by 1. So 12 will turn into 10 and 10 will turn into 9. So let's take a deeper look at this solution. So we have x increasing index when sum is less than 14, and we have y decreasing index when sum is greater than 14. So let's start by looking at the last index and the first index, which is 1 and 12. The sum is 13, so that means that 13 is less than 14. So let's move up an index and make it 3 plus 12. Well, 3 plus 12 is 15, which is now greater than 14. So let's decrease an index. 10 plus 3 is 13, which is again now lower than 14. Let's increase an index, which is 5 plus 10, back up to 15. Almost there though. So let's decrease an index, and 9 plus 5, where we found the solution of 14. This solution is extremely fast at finding the solution compared to the first option where we did a double nested loop. So let's code this solution. Let's now see if we can modify the function that we created before to think like a Google engineer and not have to loop through every single index. So let's start by creating a function. Find solution num, where we pass in a Google list param and a sum from list param. Let's make this a little more readable and add in our colon. We now want low equal to 0, high to equal the length of the Google list param we are passing in. However, since the last index is actually one element shorter than the length, because the first index is 0 of a list, we have to do a -1 at the end. We can now say while low is less than high, sum review equals Google list param at the low index plus Google list param at the high index. We can now check to see what this is. So if sum review is equal to the sum list param. So if these two indexes equal the index sum that we are passing in, well, then let's return true. And of course, for this example, let's see it appear in the terminal. Elif sum review is less than sum from list param. Well, let's add one to low, else we want to subtract one from high. And if this doesn't work after looping through all the elements, we can just go right back to here and print false, return false. So what is this doing? Well, we have a new solution called find solution num, where the lowest index is 0 and the highest index is the last element of the list. Well, while low is less than high, we want to get this sum review, which is just adding the two elements together. We want to compare sum review to the sum that we are passing in. If it's true, we want to return true as we found the solution. If it's not true, we want to see if sum review is less than sum from list param. If it is, we'll add one element to low. If it's not, we will subtract one element from high. If it goes through the entire loop and finds no solutions, let's return false. So let's call the function and pass in Google list and sum from list. And let's see what it runs. We'll see that we get the true element as 5 and 9 equal 14. If we change this to a 51, we'll see that we actually get false. The performance on this function is significantly higher than the nested loop due to arbitrary numbers, and you never know how long the list can be. I hope you learned something today, and I hope you're starting to think more like a Google engineer.